Hey there, and welcome to the first episode of how to create a voxel game like Minecraft in Unity, here on this brand new channel. So, what are we going to do today? Well, today we're going to set up our basic setup, like our world, chunk, and voxel classes, where voxel is a struct, but we'll talk about it later. We'll set some basic variables inside of the scripts, and we will call a basic world creation instance from a game manager singleton object, which is going to be a mono behavior. So if you're interested in learning a lot of programming, or if you're interested to learn C# or to learn a voxel programming whatsoever in Unity, then you came to the right place right here. So without further ado, let's just dive straight in it. So I've created a new Unity project. Let's make a new directory called scripts, and well, let's organize a bit deeper because we are going to start working on some generation components. This series will generate everything, so that's why we need to order it, and we will do some reordering later on in the series. But for now, let's stick with a generation directory. Inside of this generation directory, we're going to make one simple C# script for now, which is called world. Because everything starts off in a world in our, well, voxel game that we're going to create. A world is going to be a simple class, and at this point I can really easily talk you through what we're going to do because, well, this is basic scripting. I will explain what we're doing and why we're doing things, but yeah. So if you just followed along, I removed our mono behavior system because we are not going to need mono behavior in the world class, but I do need a namespace which we are just going to call generation. I'm not going to add like my Josie in front of it or whatsoever. It's just going to be generation and a world. And let's make a default constructor for now, so we can do something with this later if we need to. Now let's make a second script because next to a world, we're going to do some magic with 3D chunks. And a chunk is a way to actually just show do not overload our CPU or GPU, so to say. So we're going to store data instead of chunks, and a chunk is going to be a 3D chunk. So it got a depth, a length, a depth, and a height. So X, Y, and Z component there. So let's make another class called chunk. Let's put this one in the correct namespace as well. So it's just going to be in generation. And again, this first video will be pretty quickly, because, well, I don't think that we're going to do that much of like really advanced coding, and I want to get started and up and running in the real coding and the real challenging parts real quickly. So with a chunk, we do need a constructor as well, and let's keep it with that as well because we're not going to do any filling in as of right now yet. And then this chunk will actually have some voxels, so let's create a voxel class. It's going to be in the generation as well. Let's remove this, and for now, yeah, we keep it a class, and it's a voxel, and that's it. So here we go. We have a world, chunk, and a voxel setup. Now the world will have chunks because, as you recall to the beginning of this video, a world is going to be the holder of everything. So if we have like multiple dimensions, just like in Minecraft, you have the overworld and the nether and the end. For example, these will be like dimensions, but they will be live inside of a world. So then we'll add a new structure called dimensions. So we can load one world, load a specific dimension, and load chunks in there. For now, we're just going to work with one overworld situation, but later on in the series, we might actually implement like multiple dimensions in there. So a world needs chunks. So let's just store them as a list of chunk for now. Before I forget, I should zoom in a bit more because otherwise it will be pretty hard to read. And this also makes sure that, well, I'm not going to write long code parts. So if the first bit was a bit like hard to read, here you go. I've just zoomed into 161%. I'll put this one exactly at 150. So all of our videos will actually just be at this zoom level. So that's a bit better for you to read. So let's call this chunks. And it's going to be a new list of chunk. For now, if we generate a new world, we're just going to add a hard-coded chunk. So let's do chunk C equals new chunk. And of course, as you can see, this series requires you to have some knowledge about C#. Because I'm not going to explain like how to create classes and how to create that kind of stuff. This is a pretty like advanced course, so to say, on how to generate your own voxel game. Now, we are going to work with like protection and that kind of stuff. So let's already say that this is only a getter with a private setter. Because otherwise we can just do anything we want from outside of this world class, and we don't want that to be able to be happening. So now that we got our chunk, this code here, this creating of the new chunk and adding it to our chunks list will be temporary. And this one will be gone after we've done some more math and some more nice coding stuff. So let's not worry about that too much yet. Now, instead of our chunk class, what is a chunk? Well, if we just define this chunk as a chunk like this, then how do we know where to render stuff? How do you know what to do? Because a chunk, as you recalled, will like be a part of the world. So if we don't know the position, we don't know what part of the world to render. So we're going to store that information here. For now, we don't worry about serialization yet. So we can just use the internal values of Unity, like the factor tree int and that kind of fun stuff. So in order to create this chunk, we do need a factor tree int. So a factor tree int is an internal thing of Unity. So if we include this using Unity engine line, we can actually use this as our position. And this is a world position, but with indices. So I'll explain it a bit more clearly a bit later on, but for now we just save this one. So we say public a factor tree int our position, and this one is just going to be a getter and a private setter because we do not want it to be able to be set from the outside world. One thing to note as well is my notation, like I use an underscore position here as an input, and I use a capital P here. This is all personal preferences. You don't have to follow me in there, and you also don't have to follow me in the naming conventions. Also, if you like to document things, I don't like to document things if it's clear. So my chunk, the position, I'm sure that this is the position of the chunk, so I don't have to write a comment position of the chunk because the name is self-explanatory. So please, don't do this. This is not good practice. Now that we got a chunk, we got a position, but now we got an error. If you go to our error list, you'll see it. Because we, of course, need to specify the position of this first initialized chunk that we generate. So let's create a new factor tree int on the position of 0, 0, 0. And, well, if you don't like this annotation here as well, you can just add the using Unity engine or use a shortcut, and then it will add it as well. For me, it's just a control dot, and then I'll get like the help list so I can see what I can do with this factor tree int in this case. Now, we're going pretty fast, right? But that's also the point of this video, because this is the initialization, this is the setup, and we need to go pretty fast here. Now, if you've got a chunk, we want something in here, because how big is a chunk? Because now we got the position, but a chunk is not 1 by 1 by 1. So we also need one value here, which is going to be like our size. And I'm going to set that the size of the chunk will be a cont size of 32 by 32 by 32. I'm just saying this is the int because we always will have a square value here. Now, later on in the series, I actually want to expose all these variables so we can read everything from a simple JSON file. We're also going to initialize the blocks, the textures, everything is going to be separated. So you do not have to import everything into Unity. So you can just set up everything from a JSON file and actually mod blocks into this game. And that's going to be super awesome. I'm still thinking about how to do it because I'm also still learning. But keep in mind that I want to make everything that we write here configurable by the end user. That means a little bit of like mod support, if you want to say it like that. I don't think I will add multiplayer to this because I'm not a multiplayer expert, but maybe if we want to learn it, and maybe if we get to that point, we might do it. But let's just crack on for this right now. Because we also got this Voxel class, and let's already make this one a struct. If you like have a little bit of more like experience with C#, you probably know the difference between a struct and a class, and it has to do with the reference type and a non-reference type, and like the stack and the heap. I actually forgot what the biggest difference is, but I do know that this one is a much more memory efficient in order if you just create an array, because it can never be null, for example, so it knows how to lay it out on your memory, and it's much faster to create and much faster to like read things from. But if you change it, you get a new object of that instance back, so it's not a reference type. And that makes it a little bit harder to work with sometimes, but we will generate like a difference between a class voxel and a struct voxel here in this video today, so you can see the difference. And also see like the downside of using struct instead of class, and the upsides, well, which is going to be the performance. Because if a chunk holds all the data for a specific chunk, which is laying on a certain position here, we also need its local like data, like its voxels. So for now, we're just going to work with an easy 3D array. Later on, I want to convert this to a single array, so a 1D array that contains all the data with like a nice little getter and setter function, so we can still access using X, Y, and Z components, but just storing it in a 1D array. And it's also for speed reasons. So for now, or for performance reasons, we're just going to make a public voxel array, and we call this Voxels. And as I said, we want this to be a 3D array. So we're going to make this one a 3D array. We can already just initialize this using equals new voxel array with our size, since our size is a const value, so we can initialize it here without having to like do it in here. Now, a new voxel, if you can see right here, it's nothing. So let's add a simple byte for its block. Let's call this block ID. You can call BID, you can call block, you can call it ID, whatever. Now, I did use a byte. You can use an int, you can use a float, you can use whatever. But keep in mind that your memory usage will increase if you do that, because a byte is just a simple byte, but a int, it's not a byte anymore. So just keep in mind that keeping it the data type as small as possible in on your memory footprint, it will keep your application run on a lower memory footprint, and thus it will be more fluent to all different kinds of computers. So we're going to use a byte, since I don't think right now we're going to extend the 255 block limit, and otherwise we will convert it to a short probably, and then it will be increased. And right now, a voxel always like just has a block ID. And well, you cannot do this, by the way, because you're not allowed to initialize it this way in a struct. And you can also not do it in this way by just doing this and a block ID equals this, for example, because your default like empty constructor, you cannot create it in a struct. So then you would need this byte block ID variable. And now if I need to keep it consistent, I will keep it like this. And now you can create a voxel with just a specific block ID. So it is a good com to keep your ID 0 as the main block of which you want to fill your content in. Now, I told at the beginning of this video that we're going to make a basic Minecraft-y cloney thingy. But we're going to do it a little bit different to get started. Because simple Perlin noise and that kind of stuff, there are so many tutorials already to be seen on the internet from that. And it is not hard at all. So I don't want to focus on that. So with that being said, we're going to create some sort of a variation of the Minecraft game where you will be like in an infinite world, of course, also in the up and the down axis, but you are completely covered in stone. So our main block will be stone instead of air, and air is the main block of Minecraft, which will be 0. Now for us, 0 will be stone, and then 1 will be air. So at least that's what I'm thinking of right now. There's a reason, and that is that if we do it that way, then right now our voxels, so this whole chunk, has been initialized to be stone. So I do not have to loop over this whole voxel array in order to set all the contents to it. Now, we will actually do that later on because we do need to do some things here. But as long as we're not going to generate ore generation or caves or whatever, we do not need to loop over this. But later on, if we do need ores or caves or whatever, we definitely do need to loop over this, because then we need to use some Perlin worms or whatever we're going to use for caves. And then we still need to loop over the voxels over everything. And now keep in mind that this is a local voxel. And that is important because it's saved inside of a chunk. Okay, so now that we got this, we actually got our main setup ready. So there's one thing we need to do in order to test something, and that is make a simple game manager singleton. Now, if you don't know how to create a singleton, just follow along. Now, our namespace will be empty for this one, because this is going to be like a simple game manager, which is going to derive from mono behavior. So just add it, and also, of course, use the mono behavior link, and remove the unnecessary like usings. And I don't know why, but a lot of times I see scripts with a lot of unused usings. Please clean up your scripts, programmers. Do it. You will thank yourself for it later. So let's keep it going, because otherwise this video will be too long. So we're going to make a simple awake here. We're going to make a static value. So public static game manager instance, which is going to be a getter and a private setter. And by default it's null, but then it's awake, we set instance to be this. Well, we do a check in set it in front of this. So because if instance is equal to null, we want to set it to this, but otherwise let's give ourselves our error. So debug.log error. Let's say game manager already initialized, destroying this new the duplicate instance, the duplicate instance. Why not? This is not the perfect naming, but yeah. And now we're going to say destroy this, because we don't need this. And let's return. And then we can also say that we do a do not destroy unload with our target, which also is this. And now it's going to be put inside of a different scene. So if we unload this scene, it will not destroy or not remove this game manager and keep this singleton here. And then it might actually break everything. Now let's go to our start method. And in here, we're actually just going to create a new world. So we say world is new world. And it's going to give us an error because we need to use our generation namespace. So we do a using generation. Normally you do want to put like your name in front of it, so you can do like a Josie, in my case, Josie.generation. But for the sake of simplicity, I really don't mind. Now, because this world, and this is just a preparation for the future, will be accessed a lot because all the data is stored in there. And there can only be one world active at a single time in a single instance of the game running. I like to make this a static accessible thing as well. So what I normally do with these kind of things is make a public static world active. I make this one a get private set. And right now, if we create a new world, every time that world's being created, we're just going to set this active world to this. Of course, normally you want to do a unloading and that kind of stuff if this is happening right now, but for now we don't care about that. So now later on in the tool and in the next episodes, we could just say world.active and we can access its chunks. And then in each chunk, we can access its voxels and gets its position. So in order to check if it's actually working right now, we're going in this world and we're going to say, well, let's also go into the chunk. And let's say debug.log chunk has been generated. We can say on position plus position to string. So this is just a log to see if we actually like accomplish something because, well, as you can see, there's nothing visual right now. And I hope that we could get something visual next episode, and that's what we're going to work on. And then we're going to do some optimizations and stuff because there's already a lot of optimizations that we can do here. So right now, if we go here, nothing will happen because we still need to assign our... Hello, game manager. I wanted to say we still need to assign our game manager to here. But I know what happened because I made this scene and I already made a game manager beforehand. But that recording got corrupted. Yeah, nice. And I didn't remove it from here. So now it's automatically linked. But just make sure you link it to like any object. I linked it to the game manager object because it's logical. And right now, if we press play, we should see that our chunk is getting generated. And as you can see, we get a message, chunk has been generated on position 0, 0, 0. But you, as a developer, must know that there's a lot of things going on right now because we are actually having these voxels right now. And if you now imagine that these voxels are like blocks, then you got a world. It's just not visible yet. And in the next episode, it might become a bit of a longer episode then. We're going to make a basic setup to render these voxels. And after we've rendered it, then we're going to set up some threading systems so we can render these voxels in a different thread and only use the main thread for the main stuff of Unity. So, if you liked this episode and you did learn something already, please make sure you leave a like. And, well, without further ado, I think I can just say that I'll hope to see you the next time. So, have a good day, have a good evening, have a good night, whatever time it is right now, and hopefully see you the next time. Goodbye, you. Later.